In many respects, that's a large part of what I'm going to try to do here is sort of take the big picture view of what this thing that we call DevOps is, talk a little bit about what kind of what caused it, try to take some of the hype out of the discussion, and leave you with, in some respects, some general guidance. Now, part of the thing is the DevOps discussion is generally not something that a single developer can do in their cube by themselves, right? Part of the thing is the whole DevOps movement is not something that's not like you're gonna adopt a new build tool and use it on your own personal projects, and then everybody else will slowly begin to see, oh my gosh, this is such a cool tool, we should all use that. It's not quite how this works, unfortunately. There are some things that you may be able to do, but to a large degree, this is kind of an organizational effort. This is not an individual effort. This is not like learning Elixir or starting to play around with Scala or something like that. This is really talking about the organization, the team, the projects, the whole nine yards. So it's definitely a little bit different than what we traditionally think about with respect to software developers playing around and experimenting with new tools. To give you an idea of the whole DevOps story, we kind of have to go backwards first. We kind of have to step back in time to go back to the very beginning of computing and computer science and sort of see how this whole, really how the industry evolved to end up where we are now and where DevOps wants to take us. In the beginning, God created the massive mainframe. God created ENIAC. And this was this huge, huge, huge machine that occupied many rooms, required months of engineer effort to install, built off of these radio tubes and later the more integrated circuits. They required days to program. In many cases, in the early days, you were physically, manually coordinating switches. Later, we actually got to the incredibly advanced notion of punch cards, right? You would put all of your code onto a sequence of punch cards, which would then configure the things. And God help you if you got the cards out of order. And quite frankly, the computers of the day were extremely successful by any measure. I mean, in many respects, computers were what helped the West win World War II. And in many respects, this is what put a man on the moon, right? NASA was one of the big customers of a lot of the early computers to do all of their trajectories and calculations and so forth. And was not uncommon in those days for the very big businesses to look around and say, we have a lot of computations that we would like to see done on our behalf. These computer things can do it faster than any human can with better accuracy. So yeah, we have to have one. And so a lot of people started putting them into their own buildings. Now, the calculations they could provide were pretty cool. I mean, it's pretty general kinds of calculation type stuff. But calculations in of itself were not sufficient. In a lot of cases, what we wanted to do is we wanted to actually store and track data. We wanted to actually use the machines to hold data instead of just running these calculations. So we started seeing the growth of these machines and these large drum storage, et cetera, to hold all of that data. Now, these things were incredibly expensive. I mean, these were measured in the tens, if not hundreds of millions of US dollars. This was not a trivial investment by any stretch of the imagination, both in terms of your initial outlay, what we call a CapEx, your capital expenditure, as well as just keeping the thing running on a day-to-day basis. These are not, this is not something you buy on a lark. This is something you do, you get into this world very deliberately, and you are very precise, and you spend a lot of time considering what you would purchase and why you would purchase it. In some respects, the best analogy would be today if you and or your company were thinking about buying a building. I mean, I don't mean just renting some space on one. I mean buying a building, potentially even constructing the building that you want to occupy. It's that level of expenditure and training. And the people that were necessary in order to operate them were extremely rare. In many cases, you took volunteers from within your company, you sent them off for that very specific training, then they came back, they worked very closely with like IBM or Intel executives to figure out how to operate those machines, etc. Now, anytime you bring that kind of level of expenditure into play, you start thinking that we have to take care of these people. We want to start putting these like-minded individuals together. And so we very quickly, business formed a department around people who knew how to operate and keep these things running. And those people specifically in the old days were referred to as operators, the people who knew how to operate the machine. They later got the term system administrators, but the operators were different individuals. They were quirky. They developed their own subculture. And in many cases, these were people who, I mean, if you think about it, particularly in the 60s, these were people who liked being in the basement of a building. They liked not having direct human contact in some cases. They enjoyed working with these machines that were clearly not human. They developed their own sort of approach to the world. They developed their own games. I mean, for crying out loud, who would have thought it would actually be entertaining to watch little text symbols moving back and forth across a machine screen? But this is how NetHack came to be, and so on and so on and so on. And in some cases, they were less than socially adapted. In some cases, they were downright assholes. But we needed them. I mean, these were the only people who knew how to operate these machines. These were the only people who knew how to program them in many respects. And quite frankly, the power of the machine was such that we really just needed to tolerate a lot of these folks. There is if you're really interested, there are some presumably humorous / satirical stories about operators back in these days. And the ones that were, had definitely tapped into the evil side of their world. And there's one story, one sequence of stories referred to as the bastard operator from hell, BOFH. And he's just cruel. I mean, he just punishes people. And we laugh because on the one hand, we've all probably known a system administrator that's kind of like that. Oh, you can't log in? Tell you what, send me an email and I'll fix that for you. Oh, you need your login to send an email? Damn, that sucks for you, man. So sorry. There's a certain amount of revenge of the nerds here that you just can't help but enjoying just a little bit, even until it happens to you anyway. But technology continues to advance. And we saw a next generation of machines that were smaller. Hence the name the microcomputer, right? We had these mainframe machines, and the microcomputer was one that could actually sit on or later under your desktop. And the IBM PC, in particular, was one of the most successful ones of these. And suddenly, every employee within the company could have their own computer running on their own desk. And this was really, really powerful, because now instead of submitting these shared jobs to be scheduled and executed and have the results put into a cubbyhole where you could go get those printouts and work with that data, and then later, oh crap, I made a goof. Instead of adding these two numbers, I need to multiply them, so now I need to resubmit that job. Now I can actually work with it more interactively right here on my own desk. And that was powerful. Plus, I could work with the data that was stored right here at my own desk. And so I don't have to worry about data sharing becoming a problem, a security risk, right? If I'm storing all of the HR salaries on a shared mainframe, it's possible that people who shouldn't have access can get access. Remember, the bastard operator from hell, he's still lurking there in the background. He would love to find out what the rest of the company's getting paid. And each user could even have their own programs. It began to become apparent fairly quickly that we could actually start developing some bespoke software for these desktop machines to do something that was unique to our particular company. Yeah. Everybody needs spreadsheets. Everybody needs word processing. Those are common programs that we can purchase off the shelf, slap the floppy into the floppy drive, install that onto the local hard drive, and off we go, right? Everybody can do that. But there are certain kinds of programs that are going to be unique to our particular business that we would like to have on each employee's desktop. That would be good to have. The PCs themselves, they required a certain amount of care and maintenance, but definitely on a much, much smaller, more individualized basis, right? if I install something on my PC and it destroys my PC, it doesn't affect anybody else. So yes, a system administrator will have to come out and fix whatever I did to my PC, but that doesn't affect anybody else. Contrast that with the mainframe. If something goes wrong there, if somebody writes a job that consumes all of the available CPU and never terminates, well, shoot, then everybody is denied the facilities of the mainframe, and that's definitely bad. So the operators had very, very severe constraints on what you could do with these various mainframe machines. Contrast that with the PC. If your PC goes down, nobody cares except you. We still have to get somebody out to fix you, don't get me wrong, but the costs of doing so were much smaller than what we saw with the mainframe, particularly considering some of the early microcomputers came in at somewhere between $5,000 to $10,000, adjusting for inflation. That's definitely different than the 10 million that you were thinking about in terms of entering into the mainframe world. Because we want these machines to be able to do bespoke software, we need people to be able to write that software. We need people who can understand how to program for the IBM PC, the Apple II, the Apple II Plus, later the classic Macintosh. Those require a set of skills that are a little bit different than what we've seen in the traditional mainframe world. And so we need a group of people who have, again, a unique set of skills. Now, they are similar in some respects to what we have the operators and the sysadmins doing. But the operators and the sysadmins, they're working with those big shared mainframe machines. They're learning a particular set of tools and languages that don't work particularly well on the PC. So we need a different group of people to be able to do those kinds of things. And groups of tools began to emerge as well. And the developers and the development department, again, these are technologists. You know, these are guys who don't necessarily like living in the basement, but they are comfortable living off by themselves. They don't necessarily want to talk to all of the users in the company, but they also don't want to grow in the dark like, you know, the operators and mushrooms do. So they're similar, and in some cases they have similar kinds of attitudes, but they're not the same. And we don't want to just lump them together, so the two groups started to naturally separate. They started to striate apart. We have these guys building applications for the desktops, and in some cases those groups will be attached to the various departments for which they are building software. And then, of course, we still have the operators running the mainframe down in the basement doing whatever it is that they do. Then, one day, somebody figured out how to connect these two machines together and get them to talk to one another in a near real-time fashion, right? And that guy, of course, was Al Gore, because he invented the internet, remember? Well, okay. Al Gore didn't really invent the internet. He approved some funding for DARPA, which did all of this research around networking, which had been started as far back as the 1950s. But during the mid to late 80s into the early 90s, what we saw was there was a driving force to connect these machines together. Now, there were a number of different networking standards that were floated around. Novell had one, IBM had one. The one that ultimately won was the open standard TCP/IP. And so everybody started connecting these machines together over TCP/IP. And then we discovered that there was this larger network out there in the world called the Internet, and later the World Wide Web. And so we could actually hook our machines up to that. That took a few years in order for that to progress. But what we wanted to do is we wanted these programs running on these desktop machines to be able to interact with one another. And one of the easiest ways to do that was to have a program running in a central location, running on a PC that everybody knew how to connect up to. In other words, we're seeing the birth of client-server. Now, that meant we had to have a new programming style, we had to have some new development skills, and we had to have some new operation skills, because we're not connecting up to the mainframe anymore. The mainframes were not really designed for this sort of client-server TCP/IP style of intercommunication. They were designed for much more job-scheduled batch execution. And as a part of doing all of this, we discovered some new problems. One of the things we discovered fairly quickly is when you move to a client-server style of communication, server goes down, everybody is back to being helpless. We cannot continue moving forward if the server is not executing and able to process responses. And part of what we have to do is if I'm going to update the server, then any of the clients that need updating all have to be updated before they can actually talk to the server in case we changed the wire protocol there. And if we try to do this worldwide, because remember, a lot of these companies, they don't just live in one physical location. A lot of these companies are in Europe, in the United States, in China, in South America, because a lot of these multinational corporations have offices all over the world, and coordinating a rollout across all of the operations departments all at the same time, tricky, very, very difficult. So, on top of that, we began to realize that these machines, these servers, they actually require a little bit more care and feeding than a traditional PC. Remember, in the original story, PC goes down, that hurts you, doesn't hurt anybody else. But now if the PC that goes down is being used as a server that everybody in the room is using, well, that means that that one machine, if it goes down, you're all done. And if that one machine that's acting as a server is currently running on a power strip under my desk, and the maids keep accidentally hitting the power button when they do the vacuuming late at night, yes, this has happened to me, I'm still bitter about it, then, you know, suddenly these server programs are just disappearing and nobody can get to do what they want to do. So what's the natural thing to do? Well, let's take all of these servers, let's move them into a special room, let's have those guys who know how to care and feed these really, really expensive, high maintenance machines, let's have them take care of these guys. They already know how to do operations. They know how to take care of all of those machines. Let's let them do what they do best. Because really, how different is a server from a mainframe, aside from cheaper and in many cases easier to administer, but it's the same fundamental mindset. Don't change anything because currently it works. And that's fine, except that the operations mindset is don't change anything. It works. Don't fuck with it. Now you've got developers whose principal goal is to change things. That is literally the entire point and purpose of a development department, is to write code to change things. We need to introduce a new version, we need to add a new feature, we need to fix some bugs. They are by definition introducing change, and they want to do it on those servers that the operations guys are absolutely dead set against allowing anything to change. And you can start to see very quickly where this is going. The developers want to come into the server room, put some new software on the server, and then walk away and leave the operations guys to make sure that that keeps running. The operations guys are like, no, right now we have everything working flawlessly. There's no problems. Every time you come in here and change something, problems happen. No, we don't want to let you change anything. The developers say, we have to change things. Operations say, fine. You want to change things. You need to document precisely every keystroke that needs to be done in order to make the change that you are looking to change, so that we can look at what you are trying to do to make sure that you're not doing anything what we would consider to be really, really stupid. We want to make sure that if you want to change the database that you're using, it goes through a formal review process to make sure that you're not going to introduce any inefficiencies that we're going to be responsible for. We're going to force you to create these big, long playbooks that describe precisely what needs to be done, the precise order in which they need to be done. And by the way, when you want to set foot in my server room and you want to actually make this happen, you're going to do so with all eyes of the entire company upon you. We are going to roll out VPs and executive VPs, and we're going to roll out the CTO. Everybody is going to be here when we do one of these rollouts. And so help me God, if your software doesn't behave exactly the way we think it did, we're calling you if you're not physically already here on the premises. We are going to create as formal a ceremony as possible, because God damn it, if we're going to change things, we are A, going to do everything we can think of humanly possible to make sure that that change isn't going to screw things up. Number two, we're going to make this as painful as possible so that if you want to do these, you'll want to do as few of them as possible, right? So that if we're going to do it, we're going to protect the hell out of what we're doing. There's the old saying that says, don't put all your eggs into one basket, but if you're going to do that, protect the hell out of that basket. We put all these things in one place. We make sure there's a bunch of ceremony around it to make sure we're not screwing anything up. And you can easily see what happens next. The developers are like, you guys are insane. The degree of detail that you want is ridiculous. Why do I have to tell you to CD into the directory? This is the only place where you would possibly do this. This is ridiculous. Why do I have to type, your username goes here? Why do I have to tell you that you have to log in with your password when it prompts you for your username? This is absolutely, you guys are impeding our progress. You guys are difficult to work with. We're just trying to do what our bosses tell us to do, which is to create software, and the operations guys say exactly the same thing. We're just trying to do what our bosses are telling us to do, which is to keep everything running. Major, major catfight every time we do one of these releases. And then, because it wasn't bad enough yet, then came the web. And the funny thing about the web, the internet has been around for a lot longer than the web. And the fact that most people consider the two of them to be synonymous is an indication of the fact that most people don't really understand the difference between them. The key difference is that the internet is what computer scientists use. The web is what your grandmother uses. The web is what non-technical people use. It's all about web browsers, home pages. It's all about this giant exercise in narcissism known as social media. It's about millions upon millions of people daring to venture where only computer scientists previously thought to tread. The web in particular allowed us to extend our reach. It allowed us to connect up with people. Prior to the web, when you wanted to ship a package and you shipped it via DHL or whomever, when you wanted to know the status of your package, you looked at your tracking slip, the sheet of paper that they gave you after you handed off the package. You looked at the tracking number. You picked up the phone and you dialed 1-800-DHL. I guess 800 numbers don't work here, but the moral equivalent, right? You dialed up somebody in the DHL call center and said, hey, where's my package? And Betty Sue, who's sitting there in the DHL call center, says, well, what's your tracking number? And you would rattle off that sequence of numbers, and she would clackety, clackety, clackety. And she's working on an internal enterprise system that DHL runs that keeps track of where your package is. Now, fast forward to a world where the web has kicked in. Today, we don't talk to Betty Sue. Today, we go up to DHL.com, we plug in our tracking number, and DHL says, oh, currently, your package is in Rome. And you're like, I'm shipping from Amsterdam to London. Why is it in Rome? And DHL says, whatever, man, reasons. Okay, be that as it may, what we've done is we've taken an internal enterprise system and we've projected it out into the rest of the world. Now, the large reason that DHL wants to do this, so they can fire Betty Sue. They don't need her anymore. She represents a completely unnecessary expense at this point, because if they can simply allow you to do what she used to do on your behalf, then she's just a middleman. We can get rid of her. Awesome. Great. Money, savings, gotta love that. Better bottom line. Bonuses for everybody who has a C somewhere in their title. Right? That's how this worked. What that meant was usage, instead of being measured in hundreds, thousands maybe if your company was big enough, now all of a sudden we're putting this out onto the internet where we really don't know what the usage is going to be. We really don't know. We can make some reasonable estimations. We can make some guesses. Around Christmas time, the load is going to be really, really bad. We're going to need a lot more of these servers than we currently have. The rest of the year, yeah, okay, it's going to maintain, depending upon the day of the week and maybe, holidays, in the particular geographic regions, whatever holidays they celebrate, et cetera, et cetera. Around Christmas time in the West particularly, it's going to spike, and yeah, great. That's going to be measured in the tens of thousands, hundreds of thousands, possibly even millions. Which means now that your server counts go up. We're not just talking about one server running under a desk anymore. We're talking about tens, hundreds, possibly even thousands of these machines that all need to be administered the same way that we did a single machine before. Every single time that we wanted to do a software release, remember we have to update the server as well as the client. Now the browser makes that a little bit easier. We don't have to update the client anymore. But on the server side, yeah, it's not just about a simple web server anymore. It's about a web server, it's about databases, it's about messaging systems, it's about a whole bunch of things. And the funny thing is, when you look at the costs, the complexities, etc., of doing server administration, it is not linear. If I have 10 servers, they are not simply 10 times more expensive to operate than one server. And if I have 100 servers, it's not 100 times more expensive than one server. In many cases, particularly if we talk about human management of servers, it's exponential. 1,000 servers can in some cases be 10,000 times more difficult to manage, because as soon as you fix something, I mean, just think about doing a software release, just physically saying I want to install this package here and I want to do that 999 more times, that's assuming you type the command exactly the same way each time. Doesn't allow for any typos, doesn't allow for you to accidentally forget a machine, doesn't allow for the possibility that a disk pack failed right after you did the upgrade, doesn't allow for a lot of common things, particularly when we start talking about these machines, the amount of disks and storage and blah. Oh, and then just to sort of compound that story, then we've got the mobile. And suddenly it's now not just about web browsing, now it's about having mobile applications, right? Each person has their own pocket computer that can do all these things that historically was required a desktop. And yeah, you can see how this gets really, really messy, really, really fast. And this is where most companies are at. You have developers who are creating software. They are seeking to change everything on a regular basis. You have operations teams that are basically seeking to fight the developers at every opportunity they have because they finally just got things. I mean, think about the complexity of a modern enterprise system. They finally got things working. They finally got them into a steady state. We finally have figured out that, you know, the version of RabbitMQ 9.1 that the developer said we had to use, well, it actually had this really weird subtle bug that when these messages came in at this time of night on this particular machine, when the moon was in this particular phase, then it crashed. And then they just rolled out a patch for that to 9.1.1. So we upgraded that. And now everything's running smoothly. And here come the developers telling us we have to upgrade to 9.4. When the hell did they go from, oh, there were 2 interim releases, which we don't care about, but now we have to go to 9.4, and they're telling me, oh yeah, no, it'll be a flawless upgrade. Yeah, that's what you said about 9.1, you developer jackasses. No, we're not, you got to write out these really complicated release scripts. And by the way, remember that the operations guys, every time you do a release, they have to run those scripts for every single server that's on the web. And if we start talking about wanting to have 10,000 machines, the only way the operations team can even begin to remotely consider doing this is if I have at least 1,000 operators, system administrators, whatever you care to call them, who are able to do this scattered across all the various server centers that we have scattered all over the world. So we're all of us at precisely 9:06 p.m. on a Friday night, we're all of us going to start the upgrade by looking at the script and typing it, and we're all of us going to get it right for every single one of those 10,000 machines. And meanwhile, the developers are banging at the door saying, hey, when you're done with that release, we've got another one for you because we're trying to be agile. And the operations guys are saying, you know what you can do? You can take your agile. This is where we are. This is the state of many, many companies to this day. So what do we do now? I mean, seriously, this is the state that a lot of people were in when we started talking about Agile and Agile development and so forth. Remember, one of the goals of Agile development was to get working software as quickly as possible. Get something that users could see and interact with. And if that means that I have to go through these really deep, powerful deployment scripts, if I have to go through these formal ceremonies, that really sort of inhibits the whole Agile mentality. On top of which, let's be very blunt, the the current state is not particularly exciting. It's not exactly something that we like talking about. I mean, let's be blunt. Equifax. If there is a person in this room who is not thoroughly embarrassed on behalf of our industry, that Equifax, right, this credit reporting agency upon which a lot of personal finance, the bedrock, your credit score number, this is how you are able to get loans, this determines the percentage rates that you pay for credit, et cetera, et cetera. This is deeply personal information. And 150 million people just had their deeply personal information scattered to the wind. Yahoo just recently announced that their big-ass hack back in 2013 was even bigger and even assier than they realized. Yahoo has now admitted that every single one of their 3 billion accounts was compromised. Every single one. Think about this for a second. Imagine if the medical industry stood up and said, oh my gosh, guys, we are so sorry. We totally thought washing hands was going to actually make all of you healthier. Turns out it gives you all cancer. Sorry, our bad. But there's nothing to be done about it, right? Because, hey, you know, it's 5-6 billion people on the planet. What all can we do? Oh, well. Wait, you're angry with us? You're mad at us? You want to hold us responsible for this irresponsible? No, that's totally not our fault. That's the state where we are at right now. There are businesses that literally are spending 90% of their IT budget just keeping the lights on. Bug fixes, disk pack replacements, all of these. They don't add new features. They aren't actually changing anything. They're not making things better. They're just keeping things going. 90% of how much money does your average Fortune 500 spend on IT just to keeping the lights on? And the thing of it is, there's a really, really famous quote. I can't remember. There was somebody in the DevOps community said it, and it's basically been picked up and run with. But basically, a bank is not a bank anymore. A bank is a software company that happens to have a banking license. And as proof towards this, I think it's HBS. I think it's or RBS, the Royal Bank of Scotland, actually has more software developers than Microsoft. It's reaching a point where this is the status for every company out there beyond a given size. All companies, Ford, Volvo, Volkswagen, right? Volkswagen's been in the news recently too, right? They're all software companies. In most cases, 100 years ago with the Industrial Revolution, it was about companies getting together to move atoms around, to physically take things, put them together in various ways, to give us things that we could then consume. Today, it's about companies coming together to push bits together, which occasionally may actually move some atoms around. That's the mindset. That's where a lot of CEOs, CTOs, even CFOs are starting to think where we're going. Into the middle of all this stumbles a number of people, particularly a number of folks from ThoughtWorks, the consulting company. And in particular, they start getting together to talk about ways in which we can try to improve the state of development and operations within the industry. And they have some interesting first discussions. And then later, one of these guys starts a conference series called DevOps Dayz, Developer Operations Days, and accidentally coins the phrase DevOps. Wasn't intended that way, but this is kind of the term that everybody has picked up and run with. Interestingly enough, the Netflix guys gave a presentation, I think it was back in 2008 or so, where they actually talked about no ops. In other words, let's get rid of operations altogether, which of course, as you could well imagine, made all the operations guys extremely happy to hear that they would no longer have to come to work in the morning, right? And then they discovered that that may mean that they don't get paid either, and then they got all upset, right? So fundamentally, DevOps is trying to bring the concept of development and operations together. We're trying to effectively go back. We're trying to fix the pain of 50 years ago when we took the operations folks and the development folks and split them apart from one another. It made sense at the time, but now, thanks to a number of technical innovations that we're seeing, the rise of virtualization, right? Today, when you go provision something out of the cloud, it's very likely you're not actually getting a physical machine. You're getting some virtualized, smaller fraction of a particular machine. Or in some cases, it may go the other way. The virtualization is such that your machine is actually many machines collectively working together. And we're continuing to see that virtualization continue to happen to the point where now we don't even think about it in terms of machines. We're just saying, yeah, I want some computing power, and I want some memory, and I want some hard drive, and I don't care where they live, right? So this virtualization is adding a number of interesting capabilities into the mix. But on top of that, we want to simplify the deployment process, the development process. We want to simplify the administration process. Basically, what we want to do is we want to completely rewrite the rules of the IT culture as we know it. Which, of course, I mean, you know, anytime we want to refactor code, that's trivial. So refactoring human beings, that can't be all that hard, right? Right? Of course not. Because, you know, we're all software developers. We all understand the concept of refactoring. Conceptually, DevOps, a couple of things to understand. First of all, it's an effort. And like most efforts, it really is never finished. Anybody who doesn't quite understand what I mean, let me put it to you this way. If you are married, have a girlfriend or a boyfriend, you understand that marriage is never done. Right? You can only win a certain amount of points for a certain period of time before they go stale. You have to use them quickly. And just because you had a whole bunch of points when you took your wife on vacation to Europe for free because the conference was paying for you to come out and do the talk anyway, does not mean that 3 years later you still get to talk about that and have her go, oh, you're right. Okay, you forgot our anniversary again for the 5th year running, but I forgive you. Not that I'm speaking from personal experience at all here. It's never going to be done. A DevOps effort is one of these things that when you sign up for it, you are signing up for a continuous process in the same way that quality is never done. You never reach a point where you say, yep, all of our quality efforts have paid off. We have a great high quality release. We can stop now. That was good. I'm glad we're done because that was really exhausting, but we're done now. We don't have to worry about software quality anymore or security. Equifax. It's a culture. This is not a simple matter of, hey, drop you some Jenkins and drop you some Chef and maybe a little Puppet, a little touch of Vagrant. We'll throw some Docker in there for spice. You're done. You are now officially DevOps. Go forth and code. Doesn't work like that. This is a cultural shift. This is a mindset shift. We are literally trying to change the way that we, the operations guys, the QA folks, everybody involved under the banner of IT, we are trying to change everybody's mindset. This is a cultural shift. It's not going to happen easily. It's not going to happen quickly. It does need to happen, but it's not going to happen just because some guy decided to adopt a new tool. It is a process. It is a continuous refinement, but more importantly, it is a sequence of steps that you will have to undertake. It is a sequence of steps that your operations people will need to do, that your QA people will need to do, et cetera, et cetera, et cetera. It's not just about tools. It's really easy to talk and focus on tools because we are all developers. We like tools. Tools are really easy. You do this, this happens, it's deterministic, it's very straightforward to understand, maybe complicated the first time you see it, but you can understand it, it's deterministic. We're talking about people. A large part of the DevOps mentality is talking about people. And unfortunately, what that means is a lot of this is going to feel very, very 1960s hippies. It's all about love, man. We just want to love the world. We want to love each other. You go to some of these DevOps presentations and you're literally expecting at some point that the speaker at the front of the room is going to say, come on, everybody stand up, group hug. Everybody give everybody a group hug. Pick somebody you don't know and give them a group hug. You guys want a group hug? Everybody's like, no, we're Dutch. We don't do that. Nope. No group hugs here. Sorry. The DevOps Handbook, written by Jez Humble and Gene Kim, a number of these big names in the DevOps world, they identify what they call the 3 ways of DevOps: flow, feedback, and Kaizen. And to explain what I mean by those, flow. This is in the manufacturing sense. There is a concept, by the way, by a psychologist called flow, which is kind of sort of related, but not exactly. In Mihaly Csikszentmihalyi, in his notion of flow, this is the state you get in when you're writing code and like time just somehow suspends and you're in the zone. You're feeling it. The code is just flowing. You can see exactly how everything is going to work. The classes, the design, you're writing code and it's all compiling the first time and it's all working. The tests are passing and suddenly you look and holy crap, lunch was 4 hours ago. That's flow from a creative perspective. Here, what we're talking about is more manufacturing flow. The lean folks, the Toyota production system folks, they identified what they referred to as a value stream. This is basically the sequence of events. If we imagine a picture moving from left to right, from the moment we get a customer request, this is the set of activities that the organization undertakes to deliver on that request. Now, in the manufacturing world, this is the sense of I walk up to you and I say, I would like a sandwich. And you say, what kind of sandwich would you like? We are now engaging in flow. And this, believe it or not, this has actually been studied at a lot of fast food restaurants. You look at Subway and Jimmy John's and some of these other sandwich places. Subway has figured out that, yeah, if we take you in a sequence, you stand up here, you ask your bread, you get your meat and cheese, you get your veggies, over here you pay, and then you're out. Jimmy John's, they have a slightly different model where they just say, what do you want? And we'll just relay that to these folks here in the back who will slap these things together and hand a sandwich to you and we're done. Freaky fast, as they call it. This is all the same kind of study as when you talk to Daimler-Benz, who says, all right, you walk onto the dealership floor and say, I would like a Mercedes C-Class. And they say, well, great. What color would you like it? What features would you like to have? Now, obviously, you're not going to get that just by walking through the dealership, and your car will be waiting for you by the time we're done, kind of like at Subway. But if you believe that they're not trying to get you to that point, you're sadly deluding yourself. They would love, particularly with the rise of 3D printing, car dealerships would love for you to walk in here and say, I would like a red Mazda Miata, and they would say, okay, great. How much horsepower would you like? What sort of seat coverings would you like? Do you want the CD option or not? Do you want the designer wheels or not? And by the time you reach the end there, and of course you pull out your $15,000 in US to pay for it, there's your car waiting for you. You hop in and you drive away. That would be awesome, right? All the way up until the part where you're like, oh, you know what? I said red, I meant blue. Okay. This concept of flow, this concept of the customer makes a request and then we carry through a sequence of activities until we get the customer's order fulfilled. This is something the manufacturing world has been focused on for a very, very long time. This is what the Toyota production system was all about. Lean manufacturing said we want to have a lead time of 0 and a lot size of 1, meaning the amount of time it takes us to start the process. Having all the tools and every knick-knack necessary in order to make your car already present. And when you want a car, we can deliver your car as opposed to producing 5 or 6 of them and then keeping the others in storage on the off chance that somebody else wants one of those. The lean notion was a strong influence in the whole DevOps thinking. The process required to convert a business hypothesis. It would be really nice if we had an application that we could actually include as a part of our car so that when the user gets, they get in, they sit down, they turn it on for the first time, they see, hello, Ted, And I can identify myself to the console, and it can be preset to my preferred temperature settings, my preferred radio settings. That would be a really cool little touch for a vehicle manufacturing company. That's a hypothesis. How long will it take the IT guys, the software developers, to carry that through to actual reality? Or to say this is not doable, we can't, we don't want to do it, whatever, and abandon it halfway through. Because remember, the customers in many of these flows are not going to be the actual end users, but it may be a department inside of the company that needs this. We actually want to be able to track how far these vehicles drive so that we can get some ideas to how long they drive before they need to go into maintenance and so on and so forth. The goal, in many respects, for any DevOps movement is to create fast flow. From the moment we get the idea to the moment we get working software, minimize the amount of time there. And by the way, part of that means when we do a deployment, no chaos. Because every time a deployment goes south, it screws up everything. In the same way that if I ordered a red car and I get a blue one at the end of the assembly line, I, the customer, am not satisfied with that. So I'm going to say, no, I want a red car. So all of that production was now a complete waste of time. So how do we verify this? How do we make sure that we get exactly what the customer wants when they want it, etc.? So we do that in a number of different ways. First of all, we make all the work as visible as possible. Now, we're software folks. The only people who can see our work are other software developers. I mean, let's be really, really honest. Showing somebody source code doesn't accomplish anything. We can show them that we have more code than we had yesterday, but all of us in this room know that sometimes progress comes from removing code, not adding it, right? Software is extremely ephemeral. It's invisible to most people. And so looking for ways to make that work visible is key. Part of that is why the Agile Manifesto says get to a working state as quickly as possible. Show them something. Show them a paint swatch for the vehicle that says, hey, we're going to paint your car this color. And they say, that's blue and it should be red. And you say, really? Oh, yeah, you're right. It should be red. Okay, cool. We're going to throw that away and fix that downstream. Make the work visible. Reduce our batch sizes and intervals of work. If we go back to the customer every so often, at Subway, when you're working with the person across the counter for you, the batch size is typically 1. We are working on your sandwich, sir. I'm not working on anybody else's sandwich. I'm working on your sandwich. So that when you say, I want cheese, they'll say, great, here's some cheese. And you say, I want lettuce, great, here's some lettuce. We are working focused on that one batch size. If you ever really want to screw Subway employees up, go in and order 5 sandwiches. Now the batch size is bigger, and trying to communicate which sandwich has which fixings is a really, really hard thing to do. Batch size larger than 1 really screws them up. The intervals of work. We want to get near constant feedback. This is why the countertops at Subway are transparent. You can see what they're doing. As they reach for the green peppers, you're like, nope, 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 nope. No peppers, nope, no. Not interested in peppers. Definitely put those jalapenos away. We can see that interval extremely quickly because it's right there happening in front of us. Build in quality by preventing defects from being passed downstream. That's pretty straightforward. Constantly optimize for global goals. This is the one that a lot of groups have a hard time dealing with because a lot of software development departments, we don't think globally. We think around the various things that we focus on, and we don't think about how this affects the rest of the company. That's something we start working on later. What all of this fluffy stuff means is there are a series of things that we can do technologically. We can start thinking about continuous build, integration, test, and deployment. This is where a lot of the emphasis around tools comes into play. Creating environments on demand. Chef, Puppet, Vagrant, Docker. That's what they are designed to do. Limiting the work in progress, well, that means we want to take smaller bits, we want to take smaller chunks, building systems and organizations that are safe to change. Think about this for a second. Imagine that you are the night before a major software release and you have discovered a concurrency bug in your data access layer. How many of you are going to panic? How many of you are going to sit there and say, you know what? I can fix this. I'm going to sit down and I'm going to completely rewrite the data access layer from scratch and ship it with confidence, knowing that it will work tomorrow morning. ThoughtWorks did exactly that. Night before a major software release, I think it was for Southwest Airlines. I used to work for ThoughtWorks about almost 10 years ago. And they discovered a bug in their data access layer. Dude sat down, rewrote the data layer from scratch, shipped it. And it worked because he had a whole pile of unit tests to make sure that everything behaved the way that it was supposed to behave. And all the other unit tests made sure that he didn't screw anything else up anywhere else. That's what we mean about safe to change. But it's not just the code. If you walk into your boss's office tomorrow and say, "Boss, I think I have a better way for us to produce software," is your boss going to say, "That's great, you're an idiot, you're fired"? Or is your boss going to say, "I want to hear more. Tell me more. Let's experiment. Let's try that. Let's see what happens. How would we measure that success?" That's what we mean about organizations that are safe to change. The second part of this is feedback. Flow moves from left to right. Customer makes a request, we produce it out the other end. But if we don't have feedback along the way, if we don't have the customer watching us while we make that sandwich, we won't know when we get it wrong, or we won't know until we get out the other end. This was the canonical problem with a lot of waterfall deployments. We didn't realize that what we were building wasn't actually what the customer needed until we actually put it onto the servers and let them start using it. And by that point, of course, it's already done. In the manufacturing world, this is basically, again, getting the color of the car wrong because we didn't go back and verify it with the customer. I mean, we can't just go back and say, "Now you wanted a red car, right? You wanted a red car, right? You wanted a red car, right?" Okay. We hate it when our software says that to us. "Are you sure you want to delete this file? Are you sure you want to delete this file?" And you say, "Yes, yes, yes." "No, wait. And it's too late. We want to have feedback all throughout the system so that we can see not only when we're starting to do things incorrectly, but also so that we can see where the inefficiencies are. So that we can see where, it turns out that if instead of doing 4 or 5 different manual steps right here before we can move on to the next step of the automation, we might actually be able to shorten that down by cut 3 of those people out of the loop, or train those people to actually know how to do all 4 or 5 of those steps, so that now any one of them can do this approval process, and so on and so on and so on. Feedback, this is the key element that occurs in any Agile process. And that in many respects is Agile's great donation to the DevOps community, is this notion of putting feedback everywhere. But none of this happens until all of us embrace this cultural concept that the Japanese referred to as Kaizen. Constant improvement. This is actually, believe it or not, you want to get really sort of metaphysical, this is actually part of the way of the samurai. This is part of Bushido. Now, some of this is because a lot of this originated in Japan, where they were actually sort of adapting a lot of their cultural norms. But very bluntly, there's nobody in the world who knows how to do this stuff perfectly. Even if they know how to even if we could decide what perfection looks like, and you could actually achieve it for your place of business, the context, the degree of customization necessary for your place of business means that if we lift that lock, stock, and barrel and move it to a different company, it may not work. It may not work as well. It may not be perfect. So part of what this means is those of us that want to engage in this DevOps thing, we have to be constantly looking at what we're doing. We have to be constantly looking at what other people are doing and asking these questions of, are we doing it right? You know what? Right is a binary term. There's right and there's wrong. Are we doing everything that we could be doing in order to maximize the value that we bring to our customers? Are there ways that we can improve our value stream? Are there ways that we can improve the feedback? Are there ways that we can improve ourselves individually in order to be better about all of this? Asking those questions and not being afraid of what that will do in terms of us and our coworkers. That's critical. That's what we call about that culture of safety. There are a number of myths about DevOps. DevOps is only for startups. If you count startups like Ford And I mean, everybody focuses on Netflix and Flickr and some of these other companies because they were starting from greenfield, right? They were starting literally from nothing. But a lot of the lean manufacturing stuff has been around since the 80s, and a lot of manufacturing companies have retooled and have seen some incredible success, including GE. I mean, GE is the poster child for inefficient manufacturing, right? General Electric has figured out how to adopt a lot of this stuff, not only at the manufacturing level, but also in the software side. DevOps replaces Agile. I don't know where this one came from. I've heard it in a couple of places. Absolutely not. They feed on each other in a lot of ways. Agile frequently, the attempt to be more agile, the attempt to push these things into production more quickly will often lead to a DevOps culture. So there's definitely no replacement at stake here.
Agile called DevBiz.
I'm sorry, what?
DevBiz.
DevBiz?
Agile.
DevBiz. Agile is dev business?
DevBiz and this DevOps, and they work. So
If that works for you, man. If that works for you, you run with it. I've never heard that. I don't know anybody would actually say that out loud and admit it, but, you know, whatever. However it works. DevOps is only useful in an agile environment. This one I've heard a lot, and I thoroughly disagree with it. You do not have to be a completely agile company in order to make use of DevOps. It helps. Don't get me wrong. There are a lot of principles in DevOps that are very, very supplemental and work very well with an agile mindset. But even if you're in a product company, I mean, if you're working for NASA, who is by definition the world's biggest waterfall company ever, because once they launch something into space, refactoring is really hard, right? Still possible. The Mars lander is a perfect example of that, but it's harder. And yet, when they landed the rover on Mars, they actually sent a software patch because the whole thing was written in Lisp. So they were actually able to do a certain amount of software level refactoring. They couldn't change anything about the hardware, but they were certainly able to do some software level refactoring. So yeah, this DevOps stuff is definitely approachable even if you're not currently an agile shop. DevOps is incompatible with InfoSec Security and all of those things. A lot of the InfoSec guys want to put very specific controls in place. Software does not leave here until it's been seen by Joe and he's done a thorough security review by looking at the source code. Okay, time out. First of all, the idea that a manual software review, looking at lines of code, is going to somehow make the code safer, completely shot out of the water with the whole Heartbleed. You guys remember this, the vulnerability in SSL? Because thousands of eyes, millions of eyes looked at that line of code that didn't have the curly bracket, it was just indented, and totally went right past it. Manual checks of things do not accomplish anything except a peace of mind, a feeling that somehow somebody has looked at it. Now, there are a lot of things that we can do as a part of the process that should be done as a part of a DevOps process. We should absolutely be running, for example, static analysis tools over our code to help identify potential places where there might be bugs that human eyes won't be able to spot. Absolutely, no question. Let's fold that into the process. Let's do that from day one instead of waiting for some very specific checkpoints. Part of the thing to keep in mind too, though, is a DevOps approach. A large part of it is to help make software higher quality. And every computer security professional on the face of the planet will be the first to tell you that for high degrees of security, you must have high degrees of quality. Because most security bugs are actually just bugs. So with high quality comes high security. DevOps means eliminating ops. Yay, we can fire all those asshole system administrators. No more DBAs. Yay! No, that's not how it works. Unless, I take it back, unless you developers are willing to carry around a pager 24/7. Who's signing up for that? Who wants to be called at 2 in the morning every time the web server goes down? Who wants that? Nobody? Nobody? Well then, we need ops. And more importantly, we need them to be a part of the process from the beginning. We need them to be in a part of this from day one. They need to be at the table. They need to have just as loud a voice as developers have got. DevOps is just automation. Yeah, there's automation tools that can happen, but that doesn't mean that it's just automation because, like I said, a lot of this is cultural stuff. It's only for open source. I'm not even going to give that one. First thing to realize, there's no single path. Every organization is different. There are some shared characteristics, but a lot of what we say will work for one business won't work for others. You have to do a certain amount of adjustment. Basic things you can do. Embrace questioning. Just the fact that your boss says, hey, does anybody know how we could make this better? That's a huge step. Huge step. If you could start getting to the point where questions are okay to ask. From there, know where you're starting and know what you're changing. This means creating some concrete, actionable things that we want to go after. Look for some executive sponsorship. There is an old saying, 'tis better to ask forgiveness than permission. This is not one of those times. You need executives to weigh in and support what you're doing because you are talking about engaging in a cultural mindset shift. That doesn't happen unless your boss's boss, and as far up the ladder as you can go, buys into this. For the same reason that the whole lean manufacturing movement was not something that just happened with the line workers. It's had to happen from the foreman of the plant to the VP of manufacturing all the way up to the CEO if this is going to be effective. There are a lot of things you can do that don't have to be effective, but then what's the point? Assuming you've got some support, look for a pilot project, set some goals around that project. What we want to do is we want to be able to deploy once a day. Concrete, measurable, easy to spot. We want to deploy twice a day. We want to deploy every time we do a source code integration, every time we do a git merge, every time we want to do a deploy. To the point where I think it is Amazon says now they do something like 130,000 deploys every day. Look for mentors, include everyone as a part of this. This is not just a development project. Bring the ops guys to the table, bring the QA guys to the table. They all get a voice. Otherwise, you're just basically shooting in the wind. Keep communications open and make sure that developers feel the pain. If the software fails at 2 a.m., who wrote that code? Get them in the building. Guarantee you they won't make that mistake again. Create checkpoints. This is all about getting feedback. And then once your pilot is finished, you've actually gotten it out, cool. Declare victory and celebrate. Ceremonies are important to human beings. People need to know that we've reached a level of success. So once you've reached that goal of we now do deploys 12 times a day, every developer does at least one deploy during the day, whatever that checkpoint is. Once you've reached it, party! Buy some beer, buy some pizza, give everybody a chance to celebrate the fact that we have taken our first steps down a DevOps process. It's about shortening the flow time. It's about adding feedback loops. It's about understanding that this is something that we can do. It is a cultural shift. Some resources. These books are all highly recommended. The DevOps Handbook, again, that's where the 3 flows are described. The Phoenix Project, by the way, is a great one to give to your management. This is basically a parable, a fable. It's an Aesop's fable for the modern day. Some poor schlub gets promoted to VP of technology, and he inherits this incredibly broken, dysfunctional company. This is actually, it's actually told from this guy's perspective. And of course, as he starts down this path, he runs across this Gandalf-like figure who's one of the board members who takes him up to a high catwalk over the manufacturing floor and starts teaching him the processes of lean manufacturing and using that as a way to analogize how you want your IT development team structured. So this is a great one to give to management for them to read. The rest of these are particularly more software focused, particularly these last 2. And Mandy, somebody or other, I can't remember who does the DevOps culture. It's an O'Reilly book. But Mike Nygaard's Release It just reached version 2. He just did a 2nd edition of the book. First edition of this book, seriously, best book that nobody has ever heard of. This is every bit as good as Pragmatic Programmer. Freely admit, Mike's a buddy of mine, but this is an awesome, awesome book. And continuous delivery is a large part of the early steps of DevOps in terms of integrating continuous integration, continuous deployment, et cetera, et cetera. Jez Humble and David Farley are both ThoughtWorkers. Jez is a part of the DevOps Handbook. So there's a lot of references to the ThoughtWorks community in that. Okay? You now know DevOps. Go forth. and B, dev and op both. See ya.